All right, number 10, we're going to interpret the graph of a quadratic function. It says a small independent movie company determines the profit P for producing N DVD copies of a recent release is P equals negative 0.02 N squared plus 3.40 N minus 16. P is the profit in thousands of dollars and N is in thousands of units. How many DVDs should the company produce to maximize the profit? So maximizing the profit, anytime we see maximize or minimize, that's a key word that tells us we should find the vertex, and then we can interpret what the vertex is telling us. So this is our quadratic function up here, n squared, because our variable is squared, that makes it a quadratic. That is in standard form, so we're just going to follow our standard form. X equals negative b over 2a. So negative, and our b value is a 3.40, divided by 2 times a is a negative 0.02. So that's a negative 3.40 divided by negative 0.04. And when we do that division, we get 85. So our vertex has 85 for the x. Let's find the y value. So, or in this case, I guess the n value, but we're going to plug in this 85 for our n's here. So, oops. So our p will be negative 0.02 times 85 squared plus 3.40 times 85 minus 16. Kind of ran out of room there. And that gives us 128.5. So that finishes off our vertex, 128.5. Now what we want to just keep in mind, since this quadratic function has context to it, this 85, which is in our x spot, is really this n variable. And they told us that the n stands for n DVD copies. And I think, is it in thousands? Yeah, so it says n is in thousands of units. So this is 85 or 85,000 DVDs. And then this 128.5, when we plugged in the 85 here, that's giving us a P, and that is our profit. And that profit is in thousands of dollars as well. So question A, how many DVDs should the company produce to maximize the profit? So this is where the profit is maximized. That's going to be, let's see, this is a negative a value. This will be the highest point on this parabola. And how many D's does it take to reach the profit? Well, that's what our 85 is telling us. That 85 or 85,000 DVDs. What will the maximum profit be? Well, right here, that 128.5. So the maximum profit is 128,500. So that 128.5 just in thousands. So again, a problem like this, when you guys see, if you have to maximize something or find the maximum or the minimum, it's all about the vertex and then just understanding what information this vertex gives us. All right, number 11, solve each quadratic equation by factoring. So when you solve a quadratic equation by factoring, you do want your quadratic equation set equal to 0. So this is ready for us to factor. This one will fix, this one will fix. When it's set equal to 0, you want to first check, do we have an x squared? These are our easier trinomials. So we have an x squared, which means we can go right to 3. What are factors of 3 that add up to our b value of negative 4? And that's going to be a negative 1, negative 3. Negative 1 times negative 3 is positive 3. Negative 1 plus negative 3 is negative 4. So this is ready for us to factor. x minus 1, x minus 3. I'm going to carry down the equal 0. So essentially, what we're doing is we're trying to solve an equation that has an x squared term and an x term. These are not like terms, so we can't put those together and just solve for x like we would with, all the other types of equations you guys have solved before. So we need other methods to solve. When we factor, we took our x squared and now we broke it down into an x to the first power and an x to the first power. And because these two factors are multiplying together to give us 0, then we have this thing called the zero product property that lets us take each factor, set it equal to 0, and solve each one. So we would add 1 and add 3. So our two solutions are x equals positive 1, positive 3. We could check our answer to this by graphing it and seeing if we cross the x-axis at a positive 1 and positive 3. That's what that information would give us. But this is the algebraic factoring way to get there. All right, number 12, we want to get our equation set equal to 0, like how number 11 started. So we have x squared plus 9x. I'm going to add 14 to both sides, so it's equal to 0. And now we'll look for factors of, well, first, do you notice how it's just an x squared? So let's find factors of our c, 14, that add up to b, our 9. So that's just going to be a 2 and a 7. So x plus 2 times x plus 7 equals 0. Now that it's factored, we set each factor equal to 0 using our zero product property and then solve. You'll subtract 2 and get a negative 2, subtract 7 and get a negative 7. All right, last factoring problem. We want our equation set equal to 0. It'd be very tempting to take this x squared and subtract it to get it to the other side, but then your x squared is negative. In general, factoring is a lot easier if you can work with a positive squared term. So instead of subtracting x squared to get it over here, I want to get these two terms over here where the x squared is, because that's where the x squared is positive. So we're going to have x squared, we'll subtract 11x from both sides and add 28 to both sides. We want to notice that all we have is our x squared. There's not a number in front, so we're not guessing and checking. And then we can look for factors of c, which is 28, that add up to a negative 11. That's going to be a negative 4 and negative 7. And then when we factor that, we'll have x minus 4 times x minus 7 equals 0. Once it's factored, use the zero product property and set each factor equal to 0. And then when you solve, you'll add 4 and get a positive 4, or add 7 and get a positive 7. And again, these are answers we can check by graphing this. If we graph this, are we crossing the x-axis at 4 and at 7? Okay, so in this unit, we learned a few ways to solve quadratic equations. This was the first way that we focused on. So to solve for x, we can't just solve this like normal. It feels weird to call it normal, but hopefully you know what I mean. So we have to find another way, another method, and factoring is one of those methods. Another method is quadratic formula. Another method is completing the square. So we have a few options for how to solve these. For me personally, I'm pretty good at factoring. I've been doing it a long time. So when I see this, factoring seems like way less work than any other method I might choose. So I always try to factor first. If it's factorable, I got my factors, I have my answer, I'm moving on to the next problem. If it's not factorable, then we might think about some other ways to solve. All right, next set of questions. Identify the intervals on which each quadratic function is positive and negative. All right, so for problems like this, we want to know where our function is crossing the x-axis. That's where it shifts between positive above the x-axis and negative below the x-axis. So algebraically, for a problem like this, what I would want to do is find out when our function is equal to 0. So I'm going to say 0 equals, but I also notice there's a negative x squared. So I'm just going to factor a negative 1 out of these terms. And now, is this factorable? X squared plus 6x plus 8. This negative 1 is just going to stay out front. Do we have factors of 8 that add up to 6? And we do. We got x plus 2 and x plus 6. So kind of that tricky x idea, or if I were to actually solve these, set them equal to 0, I know that we would have x equal to a -2 and a -6. On a graph, this is where we cross the x-axis. So -2, -6, and with a negative a value, which is now out front here, we know that this parabola is opening down. So it's going to look something like that. Now, we have to write intervals in which the quadratic function is positive. So it's positive. Let me just do a little highlighting for you. Here's where it's positive when it's above the x-axis. So I can see, oh yeah, well that's from -6 to a -2. So how we would write that is, let's see, we could write it two ways, I guess. -6 is less than x, which is less than -2. Again, I used less than. I didn't use the or equal to bar because we want to know when a graph is positive means actually above it, not negative below it. You also could write that in interval notation. You could say from -6 to -2, and then use parentheses because the -6 and the -2 are not actually part of the interval. So that's figuring out where it's positive. Where is it negative? So let me highlight the negative parts of our graph where it goes below the x-axis here and here. So where that happens is on the left side of -6 and on the right side of -2. So where's our graph negative? In interval or in with inequalities, would say x is less than -6. That's from our -6 to the left. We're down here in the negative part. And when x is greater than -2. So when we're greater than -2, we're also down here. So that's how we would write that with inequalities. We also could use interval notation. We would say from -infinity to -6, not include either one. And then we would say from -2 all the way to positive infinity. So a couple different ways to write out that answer. Okay, one more like that. This one is saying we have y equals 2x squared minus 4x minus 16. So we want to find where we're crossing the x-axis. So where are those x-intercepts? If we can factor this to figure that out, great. One thing I noticed is there's a 2 in front of the x squared, but I also noticed that I can factor a 2 out of all four terms. So that's going to leave me with x squared minus 2x minus 8. Now that I have factored a 2 out, can I factor this? Do we have factors of -8 that add up to -2? And we do. That's going to be a -4 and a +2. So our x-intercepts are going to be at +4 and -2. So if we think about what that looks like, let's see, +4, -2. Our parabola has a positive a value, so it is opening up. Now to open up and go through these two intercepts, that means the vertex must be down here somewhere. So we'll go ahead and draw on that vertex, or draw on that parabola. And then let's figure out, where is our function positive, where is it negative? So positive is when we're above the x-axis. So we're above the x-axis here, and we're above the x-axis there. So it is going to be two different intervals or two different inequalities. Oops. So where's our graph positive? It's positive on this side of -2. That's when all the x's are less than -2. And it's positive on this side of 4. So that's when all the x's are greater than 4. Or we could say in an interval notation, from -infinity all the way to -2, and then from 4 all the way to positive infinity. All right, last one, where is our function negative? So our function is negative where it dips below the x-axis, right here. So from -2 to +4. In interval notation, with inequalities, we would say -2 is less than x, which is less than +4. Or we also could use interval notation, which says from -2 all the way to +4, and we don't include those ends because that's on the axis, not actually above or below it. Okay, last problem on this page. A rock is thrown upward from the edge of a bridge and onto a road that is 10 feet below the bridge. The function h of x equals -x squared plus 3x plus 10 gives the height, h, in feet. The rock travels in x seconds from the time it was thrown. When will the rock hit the road? So when we see questions like this, first, if we notice that it says when, that means we want to find our time. In this case, our time is represented by x, so we're going to solve for x. And then when does it hit the road? What is the height when it hits the road? That's when our height is equal to 0. We don't have any height, we're on the ground. So what we're going to do is we're going to set our function equal to 0. So here's our height, 0 is equal to -x squared plus 3x plus 10. So my first instinct is to factor this, but I also notice that there's a -x squared. So I'm just going to divide both sides of this equation by a -1. 0 divided by -1 is 0 equals, leaves us with a positive x squared minus 3x minus 10. And now we're going to factor. We have just an x squared, so we can look for factors of -10 that add up to -3. And that's going to be a 2 and a -5. So we have 0 equals x plus 2 times x minus 5. And then when it's factored, we set our factors equal to 0 with our zero product property. And we get x equals, we would subtract 2 to get a -2, add 5 to get a +5. Remember, x is representing our number of seconds, so this -2 does not make sense in the context of this problem. So that's not a solution, but this 5 kind of looks like an S. Looks a lot like my S's. 5 seconds, that's when this rock will hit the road when the height is 0.